We're on.
Cool.
So, Dr. Karam, if you don't mind, introduce yourself. I, uh, I can introduce you as one of my best professors that I had like ever in the computer science field. And if you don't mind, I haven't seen you for like maybe 20 years or something. So if you can introduce yourself.
Thank you. Yeah, my name is Orlando Karam. I was born in the U.S., grew up in Mexico, came back for my PhD. Got my PhD in computer science from Tulane University about God, more than 20 years ago. I'm old. Um, I taught in a couple of places before I landed at Southern Polytechnic State University, which is now part of Kennesaw University. I was a computer science professor there for about 10 years, got tenure, um, and then decided to go into industry. So I went to Microsoft for a couple of years where I was an SDE, but really working as a data scientist. The term wasn't used much at the time. This is almost 10 years ago. Then from Microsoft, I went to Fabric.com, which is a subsidiary of Amazon, and I worked there as an SDE. I was doing kind of everything from I used a lot of Spring Boot. We also had a .NET app and some database stuff, and I started using AWS a lot because we were part of Amazon. Um, and then I moved to AWS proper as a technical curriculum developer, where I'm officially more developing courses and curriculum, but I also develop software. And so I'm really working out right now more as a technical architect or an SDE because I'm developing software for creating better courses.
Interesting, interesting. There's a lot that I didn't know since we lived like 20 years ago. Yes. So the target actually here is I will explain to you what I am, the Codeyai, the project that I came up with, and probably I will explain stuff, and then maybe we can go through like an example, and then I want your feedback to tell like me first and everybody secondly is what do you like, what do you think the improvement should be, and what you don't like as well, if any. So
Cool.
I will open up the application and let's start by here. So the way it works is, as I just mentioned a few minutes ago, like everybody, or maybe you need a way to create. If you're gonna create a like a Spring Boot application, you need a way to create the structure of the
Yep.
project. And then if you remember rational rows, that it was an architect tool so that you can create diagrams, and the diagrams will give an explanation of the classes, or the implementation side. And from there you can take that and you can generate a shell classes that developers will use to write code in them and so on. So, and lastly, you get ChatGPT, where ChatGPT can really implement the logic, and you can give it like a prompt, and it can write the code itself. So
Cool.
what I came up with actually is all these combined together, starting from Spring Initializer. If you, for example, if we create here a new project, then you have here the choices of uh, either like a Maven project or a Spring Boot project. And soon we will have a C plus, C sharp, and .NET and React, and
Yeah.
other languages as well. So if we, for example, go now to a Spring Boot project, then this is where the Spring initializers part of the application does. You can choose your metadata, and you can write your, for example, here we can change this to Codeyai, and we can choose the Spring Boot version and the Java version and the packaging, whether it's jar or war.
Yep.
And if we click next, this is where it lands us on similar to the rational row side, where you can build up the diagrams. And as a start, because we choose Spring Boot project, as a start, we get this default class that have the main method, which is the entry point for the Spring Boot project. And then you can drag and drop here classes, and you can write class one, and in the class one, for example, you have the annotation you can put on top of the class one, you have the implementation, and you have the extend, and also you can choose parameters. You can click here, you can add as many parameters as you want, and for each parameter you can edit the name, you can edit the type, and you can edit the scope, whether it's public, private, and so on. And also you can add the annotation of the parameter if there is any.
Yeah.
And also you can add the functions. You can add 1 or 2 or as many as you want. And the same way you can add the scope. You can change the scope. You can change the return type, and you can add the arguments to the function, and you can add for sure the annotation for the function. So it's pretty much like a very intense class where all the functionality of the real life functionality is added to that diagram. So for example, if we delete this one now and we just focus on the one that we just talked about before, okay, let's talk about this one, for example, because this is the main entry of the Spring Boot. Then we have the add, and the add sign will take us to the Spring Boot application. If you hover here, you can see it. So because this is the entry point, then it adds Spring Boot application. That's the entry point of the Spring Boot application. And also the function, because it's the main, then you have the args string array, and the description of this function where it starts the Spring Boot application internally. And I have here something that is set up, so maybe it's better to go through it other than creating a new one. So here we have like similar to a calculator. And so this is the main function, and the main function have private static as a scope, and it has the arg string as the arguments, and here it has the description what this function is doing. So here I'm saying in a loop, ask user to enter 2 digits, D1 and D2. Ask the user to enter a sign, which is plus, minus, or multiply or divide. If the user enter plus, call. I'm sorry, that's not expected. Okay, so if the user enter plus or minus, then it will direct it to the appropriate class and the appropriate method within that class.
Cool.
And then it will print out the results of whatever we get from the from that function. And this is pretty much what you're explaining to the description of what this application is doing on the main side. And here, if we open this, for example, this is the add function, and here it has the scope of the function, and also it have the parameter, which is D1 and D2, and it has the return type, which is the return, which is D1 plus D2. That's pretty much what it does. It just take two digits and it add them together and return the results. So if we would, so this is actually how you build the diagram. And also you can, if you're building a diagram to build up like an architecture where you want to share it with other people, you can also deal with connection and inheritance and all these kind of things. So we're starting from here. So this is the part that's belonging to rational rules, and here's actually the nice twist that's useful, which I think it will decrease the developing time by maybe 80%, if not more. So if we click on generate code here, what's going to happen is this is the information of here is going to go to the back end, and after a few minutes we will get the file right in here downloaded as like the Spring initializers. So once so think about this, you go to the Spring initializers to download an empty project. You come to Codeyai to download, either if you like an empty project, you can do that. If you want to download and build the diagrams and build the whole structure, you can do that as well. or if you want to build a full implemented code, you can do that as well. So looking at this now, the project has been created, and we have here the zip file. And if we click here, we see the file that have all the classes, and here are the classes. So we have add, we have divide, we have main, we have multiply, and we have subtract. So if we go to main, which is maybe the most complex in this file, if we open it with any text format, then we have here the logic that we mentioned in text. It's been implemented to us as a code. And if we want to import that project to our IDE, then I have here one that I just created that is actually the one that we just were working on. And if we look here, we can open up, let me actually close all this so we can start from scratch in here. So if we click here, we have the add function, which takes two integer and return them like the sum of them together. And we have the divide function, which takes two integer and divide them, and the main, which have the main logic that we just talked about, and the multiply, which take two digits and multiply them, and we have subtract, which take two digits and subtract them. And if we were to run this application from the main, then we will get the application running. And here you see, please enter two digits, so we can write 5 and 4, and the sign, we want to multiply them together, and here you go, we have 20 as a result. So that's pretty much being done all automated for us. And that's not it, because the most hated thing for developers is unit testing, right? Like no one likes them. But here we go, we have the unit test is also being created for us. So if we were to run the unit test here, we will get like test passed because it's 1. If we run the main function, which have the calls and so on, then it runs and it 4 test was passed. So with that being said, this is actually a class that I downloaded and I tweaked because it does, when I say 80%, because it does require, we're not eliminating developers here. We're just giving them like a much better point to start from. So let me actually, I will unzip the folder and I will show you what was needed to create the project that we worked on. So here's the project, and it has the same name inside. So we're gonna override the file or the project that we had. And if we click yes, so that's gonna override here the old what I just showed you. And here you see like some errors and so on. And here this is a mistake because it's importing Jupyter. I wanted to import a JUnit 4. Okay, where it is here. So we added from Maven, add Maven dependency. So we come here, we add the JUnit.
Yeah.
And we choose whatever version we want. And once we do that, it's pretty much, we reload the POM.XML, we import the stuff. Okay, we need to import it as well. Yep. So that's what it is. We need to import this as well. So this is done. And if we look at the add, there will be maybe the, so this is something that I will just, you can add the classes to like certain packages and so on, but I will, for the sake of simplicity, I'm just gonna take this off.
Yeah.
And for the main, there is an error here, int result, which is, okay, we changed this maybe to double. Where is it in divide? We probably need to change it to integer.
Yeah.
And also to change this to int and this to int. And if we see any other problem, nothing in here where it is. Okay, this is not imported anymore because it's in the same, in the main package. So that's it. So we pretty much, whatever we build is pretty much functionable now. And let's try that by running it again. Okay, SDKs, this is just configuration stuff for the project. If we were to do that and save it and import it again. And what else was needed? If we run it again, let's see, I think there was another error in here. Okay, that was, okay, so here we go, it's working. And if we add, if we say 5 and 1, and the sign is divide or subtract, whatever, then we get 4, and so on and so forth. So we can do that 7 and 5, and we add them together. Then we get 12, and so on and so forth. So, and this is just like, I would say that this is like a hello world project. That's not is doing. We can do a much more complex stuff from there. So what do you think? Any feedback from here?
A couple of things first.
Sure.
One, I'm super impressed by what you guys have built. Like, I know how much of a pain it is to build this kind of UI, right?
It
and
was
it is very nice, right? So
yes.
I'm also impressed by what ChatGPT or those kinds of guys can do, right? Which is cool.
Yes, true.
Now, I have a couple of thoughts. One is, can you go back and forth? Can you import from code and generate this diagram?
Okay. From code, you can download, you can create the diagrams. That's not yet in the mind, because what we created is a diagram that you can go back in time and edit the diagram so that you can modify the code. So, for example, all the project that I created is right here. And if you can go back and edit them if you want, you can, for example, you can make these public, or if like any of that sort, that's doable. But we did not think, because we're not thinking of reverse engineering, we're thinking of engineering. So we didn't think that reverse engineering a code to a diagram would have been a situation where we would be interested in, at least for now. I think this is meant, it's targeting a brand new project, let's say.
So my thought was, right, like, what happens when you add a class and you already made changes to the code, right? That's what I was thinking of, going back and forth.
Yes. So I didn't actually think of that, but it's a very thanks for this addition. Actually, that's a very good point that I will probably think of it in the future. But that's actually a very good point that I didn't. I was always thinking diagram would lead to code, and if I want to change the code, I will come to the diagrams and I will change the diagrams and so on. And once I build like a starting point, I can take it and build on top of it, and then it moved now from the architecture to the implementation where it wouldn't, like, if usually when you go down the life cycle, you don't go back and, like, modify the diagram for the architecture. You just implement the code, and then it goes on and on and on. And then once it's implemented, you pretty much don't know where is the architecture was anymore, because stuff is being implemented. But that's actually a good point that I never thought of it, honestly, but I will be probably think of implementing something like that in the future.
Or at least maybe you can make it so that, like, you store a version, and so next time you only generate the extra stuff from there or something like that.
I know it is possible, because I will tell you that, for example, showing you here, here we will have an option to share a project we created with somebody else, so somebody else can have. So we pretty much, like, any of these diagrams, we can import them, and we can modify them. So I know it is possible. What you mentioned is possible, and I know that it will take some work, but it is possible. That I honestly didn't think of it at all. But thanks a lot for this addition.
Cool. Glad to be useful.
Yeah, definitely.
Like, different people are gonna try to use it different ways, right?
True.
I think it does make sense to start to say this is an architecture thing, and then you are gonna stop using it once you generate the architecture, right?
Yeah, I mean, so you're starting by building the structure, whether it's a Maven or it's a Spring Boot, and then you build. Some people, they won't even want to build a code, so they will build the diagrams and they will import. So we can import like a rational rows kind of like code that is classes that is empty, and then you write your code. Some people would prefer that. And the ultimate, which I think is the endpoint, at least for now, for that project, is if you want to build the structure, you want to build the architecture, and then you want to put like a starting point for the code, for the logic itself. And this is where we ended it. And then you import the project. You have a good starting point to add up on top of it. And I'm sure that this is to fix some stuff, as we've seen in the video, to fix some stuff and to add some logic if there is needed, or if in the future something is added. So you pretty much start now from the project in the IDE, and then you add to it, for example, and so on and so forth.
Yeah, no, this sounds uber cool. Yeah,
thanks a lot. I'm glad you liked it, and so what do you think the use of it? I mean, in my opinion, this is because I've tested it before. I mean, today is the first day that you've seen it, right? So I have worked with it before, and I can tell you that code-wise, like, on time, like in the implementation part of the code, between starting the project and ending with the implementation, I think it saved maybe about 70%, and modestly 70%. Sometimes because you modify or you fix some stuff, as we've seen here, some errors will show up in the project. So, but in general, it saved like 70+% in the development time.
I think different people are going to use it different ways, right? And so for some people it will, which is amazing, right?
Yes. And the thing that I discovered, that as the complexity of the project increases, the saving time increases dramatically. So it's like, if the project is more complex, it saves a lot more than when you just try to create like a hello world project.
Yeah.
And also it saves them the unit testing and all the other stuff that, developers don't really like it so much.
Yeah. Do you have any idea of how much is being saved from the new stuff, which is ChatGPT, versus you just built a really good diagramming tool, and so
Well, the difference of ChatGPT, you don't really have so much control, right? But here you do have a control. You can put the annotation in wherever you want it. You can put the name in like the parameters that you want. In ChatGPT, you don't have that level of control. You just
and like you are generating code at the lowest level, right? Like you are kind of bounding ChatGPT, and so ChatGPT will only generate this piece of code, right, that I'm seeing, but it will not generate the public static main because that's coming from the
exactly.
diagram, right, and it's fixed.
Yes, so you have a lot more control in Codeyai than ChatGPT when it comes to code generation. ChatGPT, you can give it the idea, and then it will give you whatever it think of the idea as a solution. But here we kind of like force the direction to do the exact solution that we want, not just a solution.
Yeah. No, so that is really cool.
Yep. And I tried it with like connecting to database. I tried it with a lot more complex scenarios. And I think we're right on top of the hour. So if you have any idea, maybe we can make it in the future. We can maybe connect again, and we can maybe test the complexity. How complex can we go far with a project to test the level of complexity that the application can handle. I have tried it, as I said, I have tried it with pretty complex scenarios connected to database, creating files in the operating system, and all kind of scenarios. Multiple, like I did like multiple hierarchical calls from one function to another, looped between like 20 classes in calls and so on and so forth. So it handled it perfectly, and I'm glad that you're here to give us your opinion of I'm really happy actually about the addition that you mentioned about the reverse engineering part, and probably we will work on that very soon.
Cool. No, this is amazing. This is really cool.
Thanks a lot. And
I'm gonna have a meeting with Tsui soon, and I'll mention this to him. It's gonna make him happy. His legacy lives on.
Okay, that's great. And I'm actually trying to reach also, as this is actually the first, you're the first person outside of my team that's seen the full implementation. I have discussed it with a couple of friends, but a full implementation, no one have seen it. You're the first. And I'm glad that because I remember the days that we were talking about web services on our classes, and no one knew what even web services were at like 2000, like in 2000 and so on. It was just the start of web services. And here we go. Now it's taken over.
Yeah.
Yep. All right. Thanks a lot, Dr. Karam. I'm going to stop the recording here, and I will maybe chat with you more